This is a video series about really understanding computer code and becoming an actual programmer. It's for people who know how to write small programs using basic language features like variables, lists, print statements, if statements, and loops, and who probably have watched a number of programming tutorials, but who still have trouble knowing where to start when it comes to writing a program from scratch. We'll use JavaScript in this version of the video. If you want to see it done in Python or C++, there are separate videos that are the same as this one, but using those languages. It's a great learning experience to see a problem solved in multiple languages. You'll find that programming languages are more alike than different. When you know one or two programming languages, you kind of know them all in a fundamental sense. Along the way, we'll build up a set of mini patterns I call pro tips, which are principles or rules of thumb that can be used in solving a wide variety of problems in any programming language. Let's start with a program that inputs a number and prints a pyramid of stars. There are two types of JavaScript programs, ones that are meant to run in the browser and ones that are meant to run on a command line or terminal interface. In the browser, JavaScript works along with HTML, CSS, and the browser's capabilities to make things happen on a web page. In this example, the HTML, not shown, contributes the text. The CSS, also not shown, contributes the formatting, and the JavaScript code cycles through the colors. With a terminal interface, Node.js lets us do things like inputting text values and printing lines on the console. In this example, the terminal gets a string of input from the user and outputs some text. For our pyramid program, we want to input a number from the user and print some output, so we'll make a terminal program called pyramid.js with Node. If we type node pyramid.js and press enter, it asks us how many rows in the pyramid. So if we enter 4 and press enter, the program prints a 4-row pyramid of asterisks. If we input 2, it prints a 2-row pyramid. If we input 6, it prints a 6-row pyramid, and so on. Let's put the sample output with 4 rows on the side here so we can refer to it as we work on this problem. Now, you might have some programming experience, and you might be able to write this program straight off. In fact, whatever your programming level, you might want to pause the video and take a moment to see if you already know enough to solve this problem. Now, if this were a typical tutorial, I could calmly write out a solution with a bit of explanation as I go. But let's suppose we don't know the solution right away. How do we start? Well, first of all, we have to ask the user for a number on the command line. Because of JavaScript's history as an asynchronous language in the browser, we'll use a special library called prompt sync, which allows us to ask the user for terminal input in Node.js without having to think about asynchronous code. We'll talk more about synchronous and asynchronous code in a future video. We just run a one-time npm command at the terminal to make sure we have the prompt sync library. Now we can use require to use the library, and use the library's prompt function to print a prompt and wait for the user's input. Okay, so we have the user's input in a variable n, and we have to print a pyramid of n lines. So it seems like we're going to need a loop, and each time through the loop we'll print a line. We can see a pattern. Each line starts with a certain number of spaces, followed by a certain number of stars. Each line has 2 more stars than the line before it. As for the spaces, the first line starts with 3 spaces, then the spaces are reduced by 1 for each subsequent line, until there's 0 spaces on the last line. So we have a growing number of stars and a decreasing number of spaces. We have a loop, and our for loop variable I counts from 0 up to n-1. Like, if the input n is 4, then the I in our loop would be 0 the first time through the loop, then 1, then 2, then 3, and then the loop is done. So it seems like we have to come up with some formula, some code expressions to convert our loop counter I into a number of spaces and a number of stars. But we might feel overwhelmed having to come up with code that will compute the right numbers of spaces and the right number of stars and also generate the desired output, the actual spaces and stars on the screen. We might be tempted just to guess at some expressions involving I, maybe I plus 1 or I minus 1 or n minus 1 or n minus I plus 1 or something like that, and then tweak the code, adding or subtracting 1 here or there until we get the right output. We might think a real programmer would just know these expressions, but I can only guess at them. Well, to make ourselves feel better, we can introduce our first pro tip. Solving a simpler problem can sometimes bring you closer to a solution, or at least help you understand the problem better. So how can we make this problem simpler? How about if we printed just the stars and didn't worry about the spaces? Or actually, how about if we just printed one star on each line? Now that we know how to do. Just print one star each time through our loop. Okay, let's run the code. We input 4 rows, and there we go. We printed 4 lines with 1 star on each line. It's a small victory, but we'll take it. Now, how can we print the right number of stars on each row? The truth is that even an experienced programmer would have to stop and think for a bit about how to compute the number of stars and the number of spaces from the loop counter I. The programmer makes a table like this in his or her head with special focus on the first row when I is 0. With this table, we can see that the first time through the loop, when I is 0, we want to print 1 star. And each time through the loop, we need 2 more stars. So somewhere in there, it seems like we're going to need I times 2. But if we just multiplied I times 2, we'd get 0, 2, 4, 6 stars. Those were all 1 less than the desired values. So if we add 1, then for I equals 0, we get 0 times 2 is 0, plus 1 is 1. For I equals 1, we get 1 times 2 is 2, plus 1 is 3. For I equals 2, we get 2 times 2 is 4, plus 1 equals 5. And for I equals 3, we get 3 times 2 is 6, plus 1 equals 7. Great, that expression seems to work. Let's put it in the code. Okay, so now we know how many stars we want to print, but how do we actually print that many stars? If you watch the Python version of this video, you'll see that we use Python's built-in ability to multiply a string by a number to make a new string with that string repeated a certain number of times. JavaScript doesn't allow the multiplication star to be used exactly like that, but it does provide a string function named repeat, so hello.repeat3 gives hello, hello, hello. But the string repeat function was not available in early versions of JavaScript, and because it's a good exercise, let's pretend for a moment that we didn't know about the string repeat function, and see how we do without it. We have the right value in our variable numStars. How can we print a line with that many stars? Well, we know about using loops to repeat things, so let's put a subloop inside our main loop. Okay, we run it. We input 4. Yikes, that's a lot of lines. What happened? Let's stare at the code. So what does the console log function actually do? It prints some text and then a new line character. That makes sense because looking back at our single star version, each star was printed on its own line. There's no way to get console log not to add that new line character, so let's think of another way to get multiple stars in one line. We can do it by building up the string of stars using a string variable. Let's start a string variable called starString as empty. And then in our subloop, instead of printing a star, we add a star to the string. Then when the string is built, we print it. Okay, we run it. We input 4. Yes, we got it. It's good that we went through the exercise of building up a string of stars with a subloop, but modern JavaScript does have the string repeat function, so we should use it. It replaces the subloop and the need for the starString variable. There we go. That does look simpler. And we'll just test it again to make sure it works. Yes, it looks good. So we're getting close to the solution of this pyramid problem. We just need to print the right number of spaces before each row of stars. We found a formula for the number of stars using a table. Let's add a spaces column to the table with the heading S. When I is 0, we need 3 spaces, at least for this sample 4-row pyramid. Then each subsequent row has 1 fewer space. Again, the key is to focus on that first row when I is 0. For the 4-row example, the first row has 3 spaces, as we just said. With a bit of thought, we can see that the number of spaces for the first row is always n-1, so that we always get down to 0 spaces on the last row of the pyramid. Here, it's 4-1, and if we were making a 5-row pyramid, we would need to start with 4 spaces, which is 5-1. So let's start our expression as num spaces equals n-1. Then, as our loop continues and I increases, we need to subtract spaces, subtracting 1 when I is 1, 2 when I is 2, and so on, which means we always want to subtract I from our initial n-1. There it is, we found our expression. Let's put it in the code. We can easily extend our print statement to print the spaces before the stars for each row. Let's see how it works. Run the program, input 4 rows. It works. That's great, but we should always check that our code works with a range of inputs. Let's try 5 rows. That looks good. Let's try 2 rows. That looks good. Let's try 1 row. Yep, just the 1 star. Let's try 0 rows. Yes, that's right also, it prints nothing. Okay, let's try 15 rows. That looks good too. We've completed the program, but there's something about this solution that bothers me. As you gain more experience in programming, you develop an inner voice, an inner critic, who tells you that even though your code may be working, it could be improved. In this case, the voice is telling us that these 2 expressions we developed for the number of spaces and the number of stars took a bit of time for us to work out. And if it takes time for us to think of them, then it's going to take time for someone else to understand the code later. And even if we ourselves come back to look at this code later, we might not remember how we got these expressions. It's not that these expressions are the most complicated expressions in the world, but our goal as a programmer should generally be to write the simplest code possible, unless there's a specific reason not to. We can put in comments explaining how we got these expressions. That helps a bit, but it adds wordiness, and it doesn't really change the fact that the expressions are somewhat complicated to think about in the first place. In fact, let's capture this as a pro tip. Code that's tricky to write is tricky to maintain, and if you need a comment to explain code, see if you can simplify the code so the comment isn't needed. Let's step back and consider whether we can solve this without these somewhat complicated expressions. Let's stare at the code again. The answer is that we can use variables to keep track of how many spaces and stars a line should have, instead of computing the number of stars and the number of spaces from scratch each time through the loop with a complicated expression. We can just start these variables at appropriate values and modify them a bit each time through the loop. So before the loop, let's start our variable numStars as 1 because our first line has 1 star. And we'll start a variable numSpaces at n-1 because the first line has n-1 spaces, as we just saw. Then in our loop, after printing a line with numSpaces followed by numStars, we simply change the 2 variables to prepare them for the next iteration through the loop. So we add 2 stars and subtract 1 space. And this all replaces our 2 complicated computations, which makes our inner code critic happy. Okay, let's see if it still works the same. Input 4 rows, and there it is, still works. Let's try 2 again. Looks good. Let's try 5 again. Looks good. In my opinion, this code is easier to read without those expressions. We can state what we did here as a pro tip. There's often a choice between using state variables versus computing from scratch each time. Counter variables like numSpaces and numStars, as used here, are an example of state variables because they keep track of the state of the program. It's often a matter of taste as to which approach is better, but as we saw here, state variables often can lead to simpler code, since we just need to modify them as they change instead of computing them each time. The downside of using state variables is that if your state variables get messed up, like if you mistakenly increment a state variable somewhere in your program, it's easy for your whole program to get out of sync and not to have an easy way to get back on track. Thanks for accompanying me on this problem-solving journey. But remember that you become a strong programmer through practice by writing your own programs. So here are 4 exercises for you to try that reinforce the concepts we covered in this video. You'll also find these exercises in the comments below. Number 1. Write a program called block.js that inputs a number and prints a block of stars, a solid square of stars, just like that. Number 2. Write a program called square.js that inputs a number and prints a hollow square of stars, just like that. Number 3. Write a program rectangle.js that inputs 2 numbers and prints a hollow rectangle of stars, like that, 4 stars wide and 6 stars high in that example. Number 4. Input a number and print a hollow inverted pyramid with that many rows. Yes, this one's a bit more challenging, but don't worry, start with a solid inverted pyramid first. Okay, good luck and have fun coding these.